So the next speaker we have today is Peter Bradley. So Peter's the newly appointed Sheep Genetics Manager. She's going to discuss what's happening in the current genetics R&D portfolio for MLA. So thanks, Peter.
Thanks very much, Sam. So as Sam mentioned, the topic of my presentation is really what's happening in our MLA Genetics R&D portfolio, and probably build upon what we've heard from both Hamish and Mick. During my presentation, we have three key areas that I wanted to touch on today, is to really, first of all, take a step back and think about what makes genetics projects unique from other investment that we might be making at MLA. And that really underpins the design and what kind of problem we're trying to solve when we go out and fund work in the genetics space. Secondly, we'll be looking at the genetics project landscape. So the idea, taking something from an idea right through to how that's adopted on farm. And then finally, what are our current and future focus areas? And I think Mick and Hamish have led into that really well. So what makes genetics projects unique? So looking at obviously how we make genetic progress on farm, the nature of genetics itself and genetics projects, and then finally looking at an example of how we've taken something from an idea right through to something that people are making progress on farm, with eating quality as an example. So if we think about making genetic progress on farm, and this is what actually gets me out of bed every morning, apart from the fact my alarm goes off, but is that, and why I love working in genetics, is there's such a clear pathway for adoption. So if we think about, as producers, both bull and ram breeders in the room, how you make genetic progress on farm really comes back to breeding values and using breeding values in your selection decision. So everything that we do is generally targeted at how do we get this as a breeding value and people adopting those breeding values. So for sheep, if you're a sheep producer, obviously using Australian sheep breeding values or ASBVs in your ram selection decisions, or as a beef producer using breed plan estimated breeding values. And it comes back to Hamish's first slide of the breeder's equation of what drives genetic progress, and it's our selection intensity. And if you think about where you have the biggest impact is selecting your sires, and that's where we use breeding values. But with the genomic era, we've also seen new products come on the market that will allow people to make genetic progress in other areas. So commercial products like flock profile in merinos to give you a benchmark of where you sit, or also some other genotype-only selection tools that Hamish mentioned previously. So the nature of genetics and genetics projects. So what makes genetics unique? First of all, whether it be applying genetics on farm or genetics projects, it's a long-term investment. We're invested in the life cycle of an animal and how long it takes to pass those genes on. So from genetics, a project point of view, we often find genetics projects run for a long period of time because we've got to actually breed the animals and fit in with the life cycle of sheep and cattle. Another characteristic of genetics is that it's permanent. So as Mick mentioned in his talk about feed additives, if you think about if you are trying to reduce methane and you put an additive in the feed, that's really good, you've reduced methane, but the next year you've actually got to go and buy and purchase that additive again. So whilst genetics can take a long time, it's permanent. If you continue to select on it, it doesn't go away from year to year. And on the same note is that genetic progress is accumulative over time, particularly if you're a self-replacing herd or flock and you're keeping those genes from year to year and continuing to buy better bulls. So genetics progress, you're in it for the long haul, but it is permanent and accumulative in your business. And a really good example of how we've taken a genetics concept from exactly that, a concept, right through to something that people are using now every day in their business. So eating quality in lamb is a really good example, and I think we'll probably see a similar timeline or pattern to this when we're looking at some of these new traits that have been mentioned, particularly around feed intake and methane. So back in 2008, 2012, in the information nucleus flock, we began to actually measure some animals for eating quality traits. we've taken that information, and in 2012, the first research breeding values became available to sheep genetics clients. 2012 onwards, we've actually had those breeders selecting for eating quality as part of their breeding program. 2016, single step, so genomic, full single step genetic evaluation for eating quality was launched. So we really are able from this point onwards to accelerate genetic gain for this trait. 2017, we launched selection indexes that included eating quality for terminal breeds. And then in 2021, we've now got, and we'll hear about it in this afternoon's concurrent session, an actual market signal for IMF in lamb. So it seems like a long time, but what it has actually allowed us to do, at the point last year when we first had market signals come available, because we've had breeding values for that trait for a number of years now, producers have actually been using those to drive genetic progress in the right direction. So this is an example of a group of terminal breeders, and this is along the bottom, we've got our time, and we've got intramuscular fat and shear force. So you can see that U shape in both graphs. So, and that U shape, when that starts to turn the genetic trend around, so we begin increasing IMF and decreasing shear force, was around the time we had genomic single-step breeding values and indexes come into play. So by having that breeding value, we've actually been able to, by the time we've got a market signal, we've been able to turn the genetic trend around and are heading in the right direction now for a number of years. I think the other important thing to note with this is it hasn't just been these two traits. These producers have been able to do this whilst continuing to increase lean meat yield, a trait that's quite antagonistically correlated with both intramuscular fat and shear force. So what is in the genetics project landscape? And I think, again, this is really important when we're considering that pipeline from idea through to breeding value. So we'll look at the delivery of genetic tools, and then the development behind the engine that is creating those breeding values that you're using at ram and bull sales. So as an overview of the delivery of genetic tools, I'm going to start at the end user. So seed stock producers and ram and bull buyers. You're the ones that are using breeding values to drive genetic progress in industry. And we'll hear more from Keely shortly in what other investment we have in this area to increase adoption. Those breeding values are delivered slightly different ways depending if you're beef or sheep. So the delivery of breeding values in beef via breed plan is through breed associations. In sheep, it's via sheep genetics. Then there's this step around creating the engine to calculate those breeding values. And currently that's done through a major contract that MLA has with Agboo, the Animal Genetics and Breeding Unit based at UNE in Armidale. So they do the work to create the analytical software behind sheep genetics and breed plan. But they have to get their data from somewhere. And that's where our genetics research and development and new trait capture data feeds in. Agboo look at that, work out, is it a heritable trait? What is it correlated with? And implement that as part of the routine genetic evaluations that are run for beef and sheep. So if we take that pillar that we looked at that's around creating the engine to calculate breeding values, and I said that there was a large investment from MLA in this area, and I wanted to take a step back and actually reflect. We've just gone into a new contract with Agboo. The old contract ran from 2016 to 2021. And if we just take time to reflect what was actually achieved in that time. So that in that last contract, we saw the implementation of single-step genetic evaluations for the major sheep and beef breeds. And that it was a world-class genetic evaluation system that we had available. And I mean world-class, not just within sheep and beef, across all intensive livestock industries. So that was a major achievement of that project. We also saw new indexes. I spoke about the terminal eating quality indexes that came out of that last contract. We also saw a similar development of the breed object software for indexes in beef. And we saw new traits being developed as part of that project. So new reproduction traits for maternal and merino breeds, eating quality breeding values, lean meat yield, and also feed intake breeding values in the beef space. The new contract that we've just entered into is going to be exciting as well. We've got new numbers, dramatically increasing numbers of genotypes coming into both beef and sheep evaluations. So the speed of evaluations is going to be really important and a key focus of that project going forward. Looking at ways we can make faster rates of genetic progress, so multi-breed genetic evaluations, and Mick spoke about the Southern Multi-Breed project as being a key enabler to that, as well as making progress in the right direction. So looking at how genetics can underpin integrity, so areas around, we've heard from Hamish and Mick around carbon neutrality and consumer acceptance. Incorporating those traits into our genetic evaluation systems will be a key part of this project. And resilience, so robust genetics and having genetic tools available to select animals for a changing climate. So in summary, we've had some world firsts delivered in the previous contract, and it's exciting to see this continued investment and looking forward to seeing what that project will deliver. Current and future focus areas. So what are our current research and development projects that we're investing in at MLA in the genetics space? The role of the National Livestock Genetics Consortium, and some take-homes on, well, you're going to hear about a lot of new traits, a lot of research projects over the next 2 days. How do you actually make the most of that on farm? So current research and development projects, we have one of our key investment areas in reference population projects. So for sheep, this is the resource flock. For beef, it's the Southern Multi-Breed, the bins, and the Repronomics project in the north. But the reference population projects are divided up into 3 key areas in my mind. First of all is around continuing to build our reference populations for traits that we already have available. So continuing to capture data on eating quality traits in lamb and feed intake in cattle. Then it's building and overlaying other projects onto these valuable resource reference population data sets and capturing new information, so overlaying feed intake and methane in sheep and methane in beef as well onto these populations of animals that we know a lot about. But there's also then looking at other ways that we can capture reference data, and Hamish spoke about a project that we had in the north where we collected, weren't so focused on capturing every single piece of information across an animal's life, and looking at, can we just look at lots and lots of animals rather than a small proportion that we know a lot about? So how can we continue to capture this type of data into the future? Also got investment happening in DNA technology, so looking at using DNA in novel ways. So can we predict the age of an animal? And we've just had a project finish up that looked at that. So taking a DNA sample and predicting how old an animal was based on DNA methylation. Also investing in projects around social science. So this is looking at what are community attitudes towards gene editing? Is that an area we might potentially be looking at funding in the future? We want to understand what our consumer thinks of that before we go and invest in that area. And also data platforms. Hamish spoke about the sheep genetics database redevelopment as a key enabler to how we're going to deliver genetic evaluation into the future, and looking to do the same in beef. Now I have to put a caveat. You would have seen this slide in Hamish's presentation. I actually created it and he stole it. So just wanted to note that on the record. But our National Livestock Genetics Consortium Task Force, they're really around identifying, well, where are we currently investing money at? Are there gaps? What are the priority areas? Thinking forward, thinking 20 years in front, like Hamish was talking about. What are the priorities? Going out for a project call and then assessing those projects. Do they actually meet the priorities that we set out to target? And the terms of reference for the recent call, we had 3. The first one was around carbon neutrality through all aspects of genetics, with a particular focus on northern beef, because we had other overlays in both sheep and southern beef already targeted on capturing methane information in those, so we had a focus on the north. Looking at sustainability, so structure, welfare, resilience traits, and then also looking at how do we reduce the cost and increase the speed of genotyping. So it's been really excited that we had $32 million worth of investment come through that call, and we're contracting those projects at the moment. So how do we take everything we're going to hear about over the next few days and apply it on farm? It comes back to the principle of having a clear breeding objective and using breeding values is still the way to make the most genetic progress on your farm. But if you're thinking about what's happening over the next 20 years, it's really aligning yourself and working with your bull and ram sources to ensure that they're involved in these projects that are capturing future traits of importance. And then considering those traits as they become available, how do they fit within your breeding objective? What direction do you want to head for that trait? So in summary of my presentation, I think the first key point, it comes back to use breeding values to make genetic progress, because we know that genetics within our flocks and herds is both permanent and accumulative. The genetics pipeline, so that flow of information that we saw, involves research and development, so projects to capture information, incorporating that information into the engine that creates breeding values, and then how we deliver those breeding values to industry. And then thirdly, considering what new traits might become available both in the future and how they fit within your business. So I think that'll be a real key take home over the course of the conference, and hearing all the exciting work that's happening, investment in the genetic space. What traits do you think will be important, and how will they fit within your breeding objective? Thank you.
So we have a few questions there now, so we'll work through the list a little bit.
Sounds good.
So the first question, so do you see any gaps in genetic investment areas, and what would you like to see filled?
Oh, good question. I think personally, before we went out with the call and before we discussed those priorities on my previous slide, northern beef and capturing CN30 or methane data and how that overlays with reproductive performance was probably a key gap, but the task force identified that nearly straight away. So that one certainly. I think we've got some really great work, and we'll hear from Brad Hine over the course of the conference in immune competence work in cattle. And I think there's been a little bit done in sheep, but I think that's going to be an exciting area as well of how that works as we've been pushing productivity traits in our sheep breeding enterprises. What impact has that been having on our other immune competence related traits? So I think that they're probably two off the top of my head. I'm sure there's many more.
Okay, thank you. So the next one we have is looking at a little bit of a different technology. So do you have any initial idea of what the social attitudes are towards gene editing in livestock?
Yeah, so I mentioned that we'd invested into this area. We have had a project finish up, so I'll give you a project code now for anyone that has pen and paper ready. L.Gen.2005. There is a final report available on the MLA final report website that actually is that project that explored it. It was quite interesting that, it depends on how you ask the question. So we actually found by asking questions, how do you feel about breeding animals for productivity, which we've been doing with breeding values, I actually found that some people didn't even like that. They thought that was manipulating the DNA of an animal. So I think it will probably have to do a little bit more work into it. It wasn't very clear cut at all. So we certainly won't be rushing out and investing in gene editing technologies without doing a lot more due diligence and understanding what our consumers are interested in that space.
That's nice. So we might skip that one because I don't want to handball you the Brownhaven case question. I might give Mick a second to think about it, and we'll come back to that question. Yep. And I'll direct it at Mick. So the next question then there has been a lot of mention about welfare traits. Is there any view to place hard restrictions around mulesing? It's a good question.
Good question, and it's probably not certainly out of my scope to answer that question. I could talk very much about what we've got available. I think from a sheep genetics perspective in particular, we've seen a lot more people beginning to record breech wrinkle and our genetic trend for breech wrinkle is reducing, which is good. We're getting plainer, whilst increasing fleece weight. So I won't comment on the view of hard restrictions around mulesing, but I think a lot of our sheep breeders are getting pressure to head that way from their commercial ram purchases, and we're certainly seeing that in the data that people are using and want to use genetics to underpin a mules-free flock. And I think it's certainly not the whole solution, but it's part of the solution towards moving towards mules-free.
Okay, so we'll have one last question for you,
Yep.
And then we'll go back to the Brownhaven question with Mick. So, how do we balance and prioritise resourcing R&D for new traits and adoption of existing breeding tools and traits that haven't yet been widely adopted? So, how do we find that balance?
Yeah, that's a good question. I think Mick also commented on before about how we now embed adoption into all our R&D projects that we fund at MLA. And genetics is a really good example, because we actually have a clear pathway to get, when we go and do R&D for methane, the goal is that we want to create a breeding value for that trait. And now that we've had now for I think about 3 or 4 years a sole role in MLA focused on genetics adoption, and we'll hear more about the new Bredwell Fedwell project or redevelopment and other targeted areas there that we're wanting people to increase adoption of breeding values. So I know it's always a tricky balance, but I think since we've got that dedicated adoption team and dedicated genetics adoption role, it's certainly helped us making sure that we are investing in adoption as well as the latest and greatest R&D.
Yeah, thanks very much, Peter. So we'll leave that goat question, so make sure you catch up with the MLA team around that ghost question, whoever asked it, anonymous. But we'll go to the
Brownhaven. What a gift. Well, I guess the reason we invested in defending the industry and taking on Brownhaven in the case was to protect our ability to have freedom to operate in the genomics area, because that was at threat. The outcome of the case was that the scope of that patent was narrowed, and we're in a position to, with the clarity of the outcome of the case, we can make sure that we're not breaching that patent and we have freedom to operate with genomics. So whilst we didn't win the case, the clarity has allowed us to ensure that we are not in breach of that patent.